Hi everyone. In the given problem statement of surrounded regions, we are given an M cross N matrix board containing the letters X and O. Capture the regions that are surrounded. There are few conditions. A cell is connected to adjacent cell horizontally and vertically. To form a region connected, O cell surrounded every region of the X can be connected with the X and one of the regions that are on the edge of the board. So basically, let us take this matrix, okay? So here, right, we have two basically, let's say zero, there are three zeros in between, right? So we will have to convert this to X because these are all surrounded by X. But the 1 0 on the periphery, right? It is going to remain same because it is in the boundary region and it is not surrounded. So let us take an example. Let's say we have a matrix which is going to be x, x, x and x. It is having value of 0 0, x, x, 0, x. So here, right, there are multiple values out here, right? So we are going to do an operation on the periphery. So basically, right, we are going to traverse this all the zeroth and last one, right? So we are going to make a operation. So it is going to be transformed like this. We are going to do an operation. So all the x that values that are there, right? We are traversing it up. So everything remains same. Now I am going to traverse on the left hand values also. I have done that. Now whenever I am getting 0, right? When I'm going to traverse from this part, right? So I got a 0. Then I'm going to do a DFS. And whatever connected values to this 0, right, I'm going to change those. So here, right, let's me change those to t for the time being, and this would be the x, and we got these values, and all the other ones, right, are remaining the same. Okay, because it was on the periphery, so we did a DFS, and whatever values that were adjacent to it, right, we just change it. Now we are going to do another traversal. So it would be basically, we are not going to go and search on the periphery, right? So our periphery values, right, is going to remain the same. And here, right, now I'm going to do a search in values that are on the between, right? So here first I got x, so I change it. Now whenever I got 0, right, I am going to change that to x because it is surrounded. So I'm going to change it to x. Now the t, right, if it is t, it is going to remain as it is, and then we can go and make one x out here. Once that is done, right, now the third operation, right, if we are able to found any t in this grid, right, just change it to 0 and we are going to get the result. So x, 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 changing the t to 0, x, x, x and x. So that is the basic idea. I hope you're able to understand, right? On the first time, we are just traversing the boundaries, all the elements. In case you're able to found a 0, right? Then we can do a DFS and whatever connected, right? So here, right, let's say we got an X, right? So we're going to move, we can move up, move down, move left and move right. Okay. So if we got a value, we are going to do a DFS and change those values to t. And this we are traversing on the periphery itself. Once that is done, right, so whatever values that are in between, right, I'm going to traverse all those element. Okay, and in case I found any zero values there, right, I will just change it to x. And now I'm going to traverse all the elements in the matrix. And here, right, if I'm able to find any values with t, just change it to 0. So that is the idea here, right? If I show you, right, which parts we are traversing, so we would be traversing only these parts. And here, right, because we found a t out here, right, then you are performing a DFS, and DFS will take its own course. And any adjacent 0 out here, right, it is going to change it to t. So that is the basic idea. So here, right, we have to use DFS. There would be multiple other algorithms also going to use. So if I jump to the Python solution, right, I think the entire code is going to be even more clearer to you. Let me jump there. So whenever you get a problem like this, right, the first thing that we should be doing, right, find the row. It would be length of our board, and the column, which is going to be length of board of 0. Now we're going to take some more values. So one of them is the visited, which is going to be a set. Now on the first thing, right, we are going to traverse only the elements that are on the boundary. So for I in range 0 to R, for J in range 0 to C. Once I have done that, I am going to do if board of I and J. So if I found a 0 value, right, then only I'm going to traverse it up. So it is O and R or I and J not in visited. And also I'm going to do one more thing. If I in, so I value, right, because I'm going to traverse the periphery, right, it is only going to be 0 or R minus 1, and J value is only going to be 0 and C minus 1. And so if it's true, right, then I'm going to call the DFS function, which is going to take I and J. And let me create my DFS. So def DFS R and C. And here, right, we have to check in few conditions. So first thing is that if R is less than 0 or R is greater than or equal to capital R, which is the entire value of the board, or C is less than 0 or C is greater equal to capital C, or board of so check your spelling. So in case, right, the value of board, right, it is not equal to 0 and R and C is already been visited. In that case, we are going to return it up, and in all the other case it's fine. Once that is done, I'm going to add that to visited R and C, and now we are going to traverse it up. So it would be basically if board of R and C is O, as I told you, right, any value that is O on the periphery, right, we are going to change it. So it would be board of R and C, and I'm going to change it to T for the time being. And then we are going to call my DFS function, which would be R plus 1 and C, DFS R minus 1 and C. Let me give some spaces in between. And also let me do one more thing, which is DFS R and C minus 1. It is basically going to take care of up down movements, right? So once all of them is done, right, because this DFS, right, if I'm at position, right, let's say 0, 0, right, it can move up, down, left and right. And so those movements, right, have been taken care in this DFS function that I have written. At the same time, right, if it's going out of bounds, so we have written a code in line number 14, which is going to take care of, means in case, right, we are out of bounds from the board indices, in that case, it is just going to return it up. So that's the idea. So I think that should be fine. And let's say if I print board, it should, means it is not yet completed. I just want to check whether the things are taken care of not. Yeah, I think again I made a mistake. And let me run it up. These codes are kind of bigger, so it is generally takes a little bit of time. So here, right, if everything would have taken care properly, the value of last O should have changed. In this case, saying it's not changed. So if I look at the output, right, I'm seeing that value of this last one, right, it has not yet changed. And if I look into the code, right, I have made one small error. So I am going to check the periphery, right, or the boundaries. So either it is not going to be an AND operation, it is going to be an OR operation. So if I in 0, either we are on the topmost or the bottommost, or on the leftmost or the rightmost, right? It is like that. So it would be OR, and it would be 0 to C minus 1. Let me run it now. I think it should work. As you could see, the value now, right, has changed, and the values on the periphery, right, it have got changed. Now a thing that we are going to do, and it is going to be same only. So any O that we are going to get, which would be not on the periphery, okay, which would be in the between values, right, there I will just change those O's to X. So for I in range 0 to R, for j in range 0 to C, if there I was checking in, right? And here I don't want to check. So it would be not in 0, R minus 1 or j not in 0 to C minus 1. I think it should be and out here. And the board of I and j is equal to O. In that case, I'm going to change that value. So BOARD of I and j, change it to X. And I don't know why I'm making the same error, which is like I'm making a spelling mistake of board, BOARD. And now if I print the value, so it should print so whatever the intermittent values of O that we're able to see, right, it should be changing those to X. As you could see, all the values, right, those were having O's, right, have been changed to X. And now the last thing, right, I will have to again traverse it up, and this time I'm going to look for all the values, and wherever I'm able to find T, I will change it to O. Range 0 to R for j in range 0 to C if board of I and j is equal to T. In that case, I'm going to make board of I and j to be O. And that's all that we need to do. Let me run it again. As you could see, the public test case is passed because we have run it properly. And if I submit this code, right, it should work fine. Let me do it. As you could see, I have submitted it properly. I can do one thing. Let me just remove this print statement. It was just, you can just add a debug point to understand how this entire flow is working. Let me remove it up and let me put it down. As you could see, it's like around 40 lines of code. Yeah, there are like multiple traversals that we have to do, but that is expected. And here, right, I do not have to return anything. We just have to modify the board in place. So that's all what we are doing. Let me run it again. As you could see, it is beating 22.67%, which is not that efficient, I would suggest. I think it can be improved. Maybe if we're doing, instead of doing so many passes, right, if we're doing it at one go. But the general idea, right, how we can solve this problem, right, is going to remain the same. So that's all for this video. See you in the next one.